Okay, everyone, my new set or series of videos is going to focus on a lot of graphing of different functions, especially the ones that you don't see very often in IM2. And since you guys are going to go into IM3 or do it for summer school, I want to give you a little heads up on it. Anyways, so how would we graph a function like this? Note it is a 3-power function, right? How would we do this? Well, whenever you have any function, guys, that has a parentheses, remember, whatever makes it 0 inside is a good place to start. And we're going to set up our table. And -3, of course, makes it 0. So again, we're just going to pick some numbers bigger and smaller. So we'll do like -4, -5, -2, -1. Again, keep these numbers in order over here, right? Keep them in order. And also, generally, if you do that, you can figure out a pattern you can follow to make your calculations a little bit easier. But anyways, so -3 made it 0. We picked a couple values smaller and also larger than -3. We have 5 points. This should be more than enough to get a decent graph started. And so let's go ahead and get started. We'll start by plugging in -5. So we'll have 1/2 -5 plus 3 cubed minus 5, right? Which is 1/2 -2 cubed minus 5. Now, to speed things up a little bit, guys, I want to remind you how important it is to get more proficient with your calculator. And all of you should have your own calculator by now. But if you look at what I just popped on the screen over here to the right, I actually completed most of the table here. So as you can see, when I get -2 cubed minus 5, I get -9. When I take this -4 and plug it in, -4 plus 3 is -1, right? So there's my -1 cubed. And that's, of course, -5.5. And we, of course, already know -3 is going to make it 0. And 1/2 0 cubed minus 5 is -5. And plugging in -2, I'm going to get -4.5. And plugging in -1, which I don't have on the screen here, is -1. And of course, from there, you can then get the graph as shown here. Okay? And let's just verify real quick. -3, -5. Notice it's going by a scale of 2 here. So each grid line is actually equivalent to 2. So if we went to -3, which would be between -2 and -4, and down here between 4 and 6, -4, right there, as you can see, is the middle of my graph, right? It's -3, -5, as shown in my table. Okay? And again, let's just verify one more point. Let's find -2, -4.5. Well, -2 would be right there. Follow the purple. -4.5 would be about right there, a little bit below the -4. But the whole point is, guys, once you learn how to set up the table properly, all you need is about 5 points, and you will get this graph started properly. And you'll be able to match it up or recognize the actual graph if given to you based upon your table. Now, the other thing I want to talk about that's more prevalent in IM3 is, as you analyze these different graphs, they're going to ask you particular things like intercept points. And so here's again our original function. If they ask me for the x-intercept, for example, that's where the graph crosses x. The x-intercept is wherever the y turns out to have a value of 0. So guess what? We're going to plug in 0 for y, and this is what we're going to end up with. To speed the video up a little bit, guys, I went ahead and paused it and added a few extra steps, if you can see there. Let me explain what I did. Once we know it's equal to 0, I know to get rid of -5, because I am solving for x, I'm going to add 5 to both sides. That's where that 5 came from. And then to get rid of this 1/2, I went ahead and times both sides by 2. So that's where the 10 came from. And then I knew, and you should know, if I do the cube root on both sides, I'm able to solve a cube function by getting rid of the 3 power. So I know that x plus 3 equals the cube root of 10. And you can see to the right there, guys, the cube root of 10 is 2.1544. And the solving for x, I'm going to -3 both sides, right? So that's why I -3 for my answer. And I get negative 0.8455, which, if you look at the... Somehow my video got shut off there, guys. But again, once I figured out and solved for x, I got negative 0.8455. And as you can see on the graph right there, this is where the graph intersects x at negative 0.846, which is 0.8455 rounded off a little bit, right? Okay, so again, how do you find an x-intercept? You plug in 0 for y. It's that simple. Okay, now what else would they ask? Are the y-intercept or intercepts? How would I find a y-intercept? A y, that's where it's going to cross the y-axis, right? Well, that's where x equals to 0. So we're going to plug in 0 for x. And so we're going to get y equals to 1/2, 0 plus 3 cubed minus 5, which is 1/2, 3 cubed minus 5, which is 1/2, 27 minus 5. And again, you could calculate this with the calculators. I've already shown you several times in this video. 1/2 of 27 is 13.5. So once I minus 5, I get 8.5. This would be my y-intercept. And if we go to our graph, you can see the graph right here crosses the y-axis as shown there at 8.5. And so what have we hopefully accomplished so far? Number one, do you know how to set up a table to at least get the graph done correctly? Number two, do you now understand that we should be able to solve for intercepts to find the x-intercept? Sorry guys, I got a phone call, so hopefully it doesn't distract you too much. But anyways, I lost my train of thought. But to find an x-intercept, y equals 0. To find a y-intercept, plug in x equal to 0. Memorize and remember that. Okay guys, so hopefully you'll rewind and watch this video at least more than once and take notes. But anyways, just to add a little bit more to this video, I went ahead and did another graph. I did this one here. So pause the video for a few moments and take note of what I did here. Okay, so hopefully you paused it. What did I basically do again? Well, I look in my parentheses. What makes that 0 is, of course, 4, positive 4. I pick a couple numbers bigger and smaller. My table is set up. As you can see right here, I plugged in each of the numbers, and over here, I showed at least 4 of the 5 values calculated properly on the calculator. So hopefully you can see that pretty well over there. But the bottom line, guys, is you got to be able to do negatives, fractions, parentheses, exponents, all of those different functions on your calculator very well. And the only way to be able to do that, guys, is you got to practice it. So hopefully you practice it as you're doing this video with me. Okay, so again, after we get the table completed, we now can get the graph. What I was showing you here, of course, is right here is one of our values in the table, 8.7, that is. And of course, right here, I'm showing you, and by the way, guys, this is actually called an inflection point. You don't really necessarily need to know that, I don't believe, but it's a good term to know that when it bends and curves the other way right there, guys, that's an inflection point. It's the middle of the graph. It's sort of like the vertex, but it's an inflection point instead. Okay, but anyways, so hopefully you agree. We could set up the table, we can get the graph set up right or done properly. What's next? How do we find the x-intercept? Pause the video real quick, guys. Hopefully you notice, how do I find the x-intercept? I plug in y equals 0. And all my work right in here, guys, I was just solving for x. And if you look to the right here, guys, I did the cube root of 18. I end up having to add 4. 6.621 is my x-intercept. And if you look at the graph right down here, right there is where the graph crosses the x-axis, right? It worked. Okay. What about the y-intercept up here? Well, you see, you plug in 0 for x. And again, pause the video here one last time if you need to. What I did here was, to find the y-intercept, I had to plug in x equals 0. And all my work in here is just, after I plugged in the 0 for x, I solved it. I got 27.33. Also, it's shown in your calculator right there, or my calculator on the screen. And that, of course, corresponds to the 27.33, which is where the graph crosses y right there. So guys, these videos obviously are going to be a little bit more lengthy as I have to explain more things in detail. There's other things I could have pointed out, but the video's already getting too long, right? So I'll try to point them out to you at a later time. But hopefully you got something out of graphing cube root functions. And I hope you take notes and watch this video and pause it and study it at least more than once. And don't be a stranger. I'll see you around.